Now let's imagine our Girl Scouts returned to the summer time frame and started selling lemonade. And our Girl Scouts found a nice little booth to use, but it's going to cost them $10 to rent. They decided, or they learned, that it's going to cost them 5 cents to make each cup of lemonade. And they want to sell their lemonade. They feel like 55 cents is a fair amount to sell lemonade to the people in the neighborhood. Well, the girls are learning that they can use our revenue and profit and cost functions to get an idea of how to build an inequality and determine how many cups they need to sell. So let's break this down and understand what revenue looks like and develop a revenue function, some type of revenue that's dependent on the number of cups that they sell. So revenue is typically generated as your price per unit that you sell. Cost, on the other hand, will include the fixed cost. In this case, it's a rent. They pay that regardless how much they sell. There's no electricity, there's no internet, nothing else that they have to purchase. Well, maybe they'll have to purchase a license from the state, but right now they just have a $10 rent. And then the cost, they're going to add on to that is a cost per cup it takes to make. Now they want to know the profit. At what point do we start making money? Well, our profit function is going to equal our revenue function minus our cost function. And that difference determines our profit or loss. So let's look at these and see if we can build into it these particular ones. So we have a revenue function with our particular set of data here, which is price per unit. So 0.55 times the unit. Our cost function, since we know our cost is a function of how much we sell, our cost is our fixed price plus how much it costs to make per unit, per cup. And then our profit, which we're all curious about, is going to be a revenue, which in this case is 0.55 per cup, minus our cost. Now you notice I put brackets around the entire cost because that's what I'm subtracting. I have to subtract the entire cost from its revenue. So let's find out. At what point, how many cups do the girls have to sell in order to start to turn a profit? Well, what's your guess? First of all, while you're doing that, let me set this up in our inequality form to help give us the right format. So we know that our profit function now is 0.55x all of that, which is my profit, we want that to be greater than, 0. It's at that point we start making a profit. Once we solve this for x, we're going to find out what's that number of sales that we must make. I'm just as curious as you guys. Combine like terms. Add 10 to both sides. Divide both sides by 50 cents. There you have it. It looks like if I sell more than 20, I start making a profit. Well, let's look at that graphically too a little bit and kind of get a sense of what's happening. So if we were to just to draw a quick little graph, and let's make some tick marks of say 5 units sold, 10, and then the money that they're making it, let's say also in batches of 5, $10, $15, $20. So we're going to make that in money, and this one is our number of X's, number of cups that they've sold. We can look at the cost function, or at the revenue function. Have a graph with a slope of 0.55x. And I want to compare that with its cost function. Sorry, I drew that kind of low. That's supposed to be a nice smooth upward trending line. All right, I hope you kind of get the idea with that. Sorry about that. What I wanted to illustrate is that we notice that right here at 20 is a break point. All this space right here represents a place where the cost is greater than the revenue, which means we're not making money, which means we have a loss. This space in between the graph after the break point represents where our revenue is greater than our cost, which means a gain or a profit. So I hope that's helpful for you to understand a little bit about a simple business function, but also too how we can look at using linear inequalities to help us find losses, gains, and breakpoints.